Hey, in this tutorial we're looking at section 13.3 on calculating probabilities and the standard normal distribution. Okay, the standard normal distribution is written as Z, okay, is normally distributed with a mean of 0 and a standard deviation of 1. Okay, so yeah, as said here, okay, it's normally distributed, mean of 0, standard deviation of 1. Okay, this simplifies our probability density function a lot that we saw in section 13.2. So it makes it f of z equals 1 on the square root of 2 pi times e to the negative half of z squared, where z is an element of all real numbers. Okay, to convert between a normal distribution value and a standard normal distribution, we use z equals x minus mu on sigma. Okay, now our mean and standard deviation are associated with the normal distribution. Okay, not the standard normal. Okay, because we know the standard normal is 0 and 1. And that's not what we're after. Okay, we're looking at the mean and standard deviation from the information we are given. Okay, our 68, 95, 99.7 rules, etc. apply. Okay, you can use any of those. Okay, if the data value lies on 1, 2 or 3 standard deviations in the mean, we can work it out by hand. Okay, otherwise we're going to use our calculator. Okay, using our we're still going to use our calculator going into our normal distribution. Just this time we're going to set our mean to be 0 and our standard deviation to be 1. Okay, and yeah, identify whether you want to be above or below a certain value. Okay, so we're going to have a look at the worked example that we've got to do here. Okay, so we're asked in worked example 3, okay, to calculate the values of the following probabilities correct to 4 decimal places. So the first one, okay, is the probability that z is less than 2.5. Okay, well, we know our mean is 0 and our standard deviation is 1, so 2.5 doesn't fall on one of our standard deviations, above or below. Okay, so for this one we would simply use a CAS calculator, okay, and we would find then that that equals 0.9938. Okay, for being below 2.5. So by being below, you just need to make sure your tail's set to the left. Okay, for part AII, okay, we want the probability, okay, that z is greater than negative 1.25, okay, but less than positive 1.25. Okay, again, we don't have, we're not on our nice numbers or multiples of our standard deviation. Okay, so we need to use our CAS calculator. Again, we would be wanting to go centered this time, okay, because we're between our two values. Again, put in your mean of 0 and standard deviation of 1, okay, and you're going to find that you get 0.7887. Okay, part B, x is normally distributed with so that's got a mean of 25 and a standard deviation of 3. Okay, we want to calculate the probability, that x is greater than 27. Okay, again, you can see with our mean of 25 and our standard deviation of 3, then this is again going to be one that we need to use our CAS calculator for. Okay, so we need to say do that, okay, and we get 0.2525. Okay, and the last one is convert x to a standard normal variable. Okay, so what we're saying here is this x value of 27, we want to find the equivalent standard normal value. So what we do is we do our z equals our x minus mu on sigma. So z equals, well, our x value is 27 minus our mean of 25 over our standard deviation of 3. So we get a z value of 2 on 3. So you could also find the probability that z is greater than 2 on 3. Okay, and that would also be our 0.2525. Okay. So that's all there is to it. This whole section is basically using our calculator, so I don't think you'll have too much trouble getting through it at all.